Good morning, Year 7 mathematicians. I hope you've had a nice Easter break and welcome back. So we're going to carry on with where we finished last time on directed number. So if you just want to draw a line along under the previous work you've done there, and the title for today is two-step equations, and then if you can put today's date there as well for me. Now your do now task, you've been given two algebraic letters, m and n. The value of m is -4 and n is -7. Now I'd like you to substitute those into expressions below, and then when you've done that, so you've got an answer for those 6 questions below, you're going to put them in ascending order. So that means starting with the smallest and getting larger each time, so be very careful with your negative numbers. Okay, so if you just pause the video now and give yourself about 5 minutes or so to finish that task for me. Okay, welcome back. Hopefully we've had a good go at these. So I'll put up the answers for each of them. So the first one, 3m. 3 times -4 is -12. -3 times m, so that's -3 times -4. A negative times a negative will be a positive, so that's 12, -14, and again, negative times negative for that one. This one I've written out fully because this is the one where people do struggle. So 5m, 5 times -4 is -20. 3n, 3 times -7 is -21. But we want to add those together. If you're adding a negative number, it's the same as taking away. So it's -20, take away 21. Then if you think of your temperature scale, it's going to get smaller, i.e. colder. So -20, take away 21, be even smaller at -41. And then the final one, when you're taking away a negative number, those two symbols next to each other mean an addition. So it's -20 plus 21, which gets us to 1. And then you simply have to rank them in ascending order. So smallest first, we've got is -41, -14, -12. Then we've got 1, 12, and 14. Well done if you got those correct. Any mistakes there, just do some of those corrections for me as well. So today we're going to look at two-step equations. Firstly though, what I've got in front of us here is a one-step equation. One step simply means you just need one line of working to solve it. Okay, so we're going to go back to looking at some bar models, and we're going to write an equation to show each of these bar models. So I'll take you through these first two. I'd like you to draw them down in your book as well, please, nice and neatly with a ruler. And then I'll give you a chance to solve the ones underneath, where again I would like you to draw the appropriate bar models for each of those 4. So the first one, we can see that the total, a and 14, added together, so a plus 14 is equal to 46. Now the whole idea of solving these equations is you want to isolate, i.e. get on its own, the letter. So the letter there is a. At the moment the 14 is in its way, it's a plus 14, so we want to balance it out by getting rid of that 14, and we would take it away. If we get rid of it by taking away, we take it off the 46, so we would -14 from both sides, leaving us in the bars just a, and then 46 minus 14 is 32, so a for that one would be 32. And then I would recommend, because now we're all well versed in substitution, is if you're to put that value of 32 back into the equation, you have 32 plus 14. Yes, that does in fact make 46, and you know you've got it correct. You can double check all of your working. Now for the second one, we've got 3 lots of b there. Now we're not going to write that as b plus b plus b. We're going to write that nice and neatly in algebra as 3b. And we know that equals 72. So this time again we still want to get just the letter on its own, but we have a problem. We've got 3 lots of a letter. If I want just one lot of it, I'm going to need to divide by 3, and again it's very, very important, so I've put the arrows like this. You'll need to do that to both sides. So 3b divided by 3 is simply b, 72 divided by 3 is 24. Now, there are 4 below that follow a similar pattern. I would like you to lay them out in the same way with the bar models there show what the equation is, and then show your one step for working, because these are all just one step, and then have a final answer, and then check that answer back into the original equation. Does it make sense? So if you pause the video now, have a go at those, and in a couple of minutes' time, then we can go through some answers. Okay, so hopefully you've had a good go at those and ended up with the answers as below. So for the first one, you should get m is 24. You would just divide by 4. Second one, you divide by 4 again, but being very careful, it's a negative number. So minus 96 divided by 4 is minus 24. For the next one, for g, you would need to take away 46 from both sides, and g would be 45. And then on the next one, same method again, you would take away 46, and that will leave you with a negative number, because 11 minus 46 is minus 35. As I say, if you've substituted those back in, you will know you are correct, and that's an excellent skill then to use in an exam. You'll know that you've got the marks for that question. So let's take it up a level. I'd like you now, there's a couple more here to do with some divisions and negative numbers. If you have a go at those 16 questions, again, pause the video for me, and in your book I would like you to write out the question and then to solve those. Now, you don't have to do a bar model each time. If it helps you, do draw one. If not, we want to see a clear line of working as to what you've done for your method to each side. Okay, let's put up some answers for this. So the first 3 sections are what we've largely covered already, so I'll race through those answers there for you. And if you can just mark your work there and then show any corrections. Just for C3 and C4, obviously 3x equals 22, so to get x on its own you would divide by 3. 22 divided by 3, you could simply leave as a fraction 22 over 3. So that's an improper fraction because the numerator, the number on the top of the fraction, is larger than the denominator. That's a top-heavy or an improper fraction. If you want to convert that to a mixed number, you do 22 divided by 3. That gives you 7, and then the remainder 1 goes back as the numerator, 7 and 1/3. Likewise for C4 if you follow that format. Okay, now for D, we haven't quite looked at these, but we'll see how we did with them. So it says x over 2 equals 7. So what's happening there is x is being divided by 2. So we would need to do the opposite to it, the inverse. The opposite of divide is multiply. So if we've got half an x, we want to get what 1 whole x is, we would need to multiply it by 2. So in that case, x would be 14. Double check. 14 divided by 2 is 7. Next one, x is now being divided by 5. So we would need to multiply it by 5. X is 30. And then hopefully we can sort of recognise what we're doing on these. X divided by 8. So we need to multiply by 8. And then lastly, D4, multiply it by 12. Okay, so just give you a score out of 16 for those. Well done if you've got all those right, especially on that last bottom row as well. Okay, so now we're going to have our first look into two-step equations. Two-step equations, as it suggests, is you're going to need to do 2 lines of working. You can't do it in one go. There's an extra bit of information you're going to have to solve as well. So once again, using the bar model, we have got 2 lots of A, that makes our 2A, added to 35, so that whole bar equals 81 in total. And the whole idea is to get A isolated on its own. So, first thing we would do is we'd get rid of the 35. We want to go with just leaving the letters on its own. Okay, so we would minus 35 from both sides, and that would leave 2A equals 46. Then the final step, we should now be far more comfortable with. To get 1 lot of A, we'd need to divide by 2, and so A is 23. And then once again, double check that with substitution to make sure that works. Okay, so got a few more on here as well. And I'd like you again just to copy these down as we go through them, please. So it's 3a plus 10 is equal to 19. Okay. Note how we've sort of changed the bar model around slightly, and we've got the total of 19 is in fact underneath with its own bar as well, just to show it a little bit clearer. So the very first step we've got is it fully drawn out, and once again we can see we have got rid of the 10 first because we want to get the letters on its own. So if we're taking off 10 from the top, we would take it off from the bottom one as well. So we would end up with 3a equals 9. And then the final step to get a on its own would be to divide by 3. A equals 3. Substitute it back into the beginning. 3 times 3 is 9, plus 10 is 19. We know we got that one right. Okay, and the other thing we're going to look at as well is turning some of these equations around. So 3a plus 10 equals 19. Could we also use this to show that 19 minus 3a equals 10? Okay, so we should know straight away that that would give the same answer, that a equals 3. But we're going to have a look at moving around some of these bar models, and what is in effect is rearranging the original equation. Does it still mean that same thing? Okay, so let's have a look at one more here. This is it, as I say, shown the other way round. Now, if we were to say 8 minus 2x equals 3. Okay, so what I'd like you to do is just to pause the video, have a look to see if you can understand where that equation has been created from. Thinking again back to things like our fact families that we looked at, what facts can you see from the bar models? Then have a go at solving it, and then have a look. There's 4 more below. Does that bar model help you to solve those equations as well, or perhaps a different method be more useful for any of the others? So I'll just give you a chance now, if you pause the video, to have a go at that for me, please, in your book. Okay, so welcome back then. Hopefully we've had a go at this. So this is very similar to the other ones we've looked at, but previously we may have expected the equation to be 3 plus 2x equals 8. Okay, but obviously, like I say, with fact families, there's various ways we could write this. We could say that 8 take away 3 would leave 2x, so 8 minus 3 equals 2x. So likewise, if I was to do 8 minus the other side, 8 minus 2x, that would leave the 3. So 8 minus 2x equals 3. Again, there's various different ways we could write that. Hopefully then, by solving it, you got the answer of x equals 2.5. Okay? And then to solve the equations below, 2x plus 3 equals 8 is exactly the same bar model there. So you should be able to do that straight away and get x equals 2.5 again. Next one though, got to be very careful that 2x minus 3 equals 8. So I would in fact add 3 first and you get 2x equals 11, then divide by 2, get x equals 5.5. Next one, x divided by 2 minus 3 equals 8. Very important, I would get rid of the minus 3 first. Okay, you don't want to double it to get x on its own first because it's half an x, so you don't want to times it by 2 just yet. Add 3 first, so you get x divided by 2 equals 11. Then as x is being divided by 2, you need to times it by 2, get x equals 22. And on the last one, okay, we could minus 8 from both sides. You get minus x over 2 equals minus 5. And then you would times by 2 and get minus x equals minus 10. Okay, that then becomes very, very awkward to convert back into a positives. So I would always recommend for that last one is if you've got a negative value of x, so in this case we've got minus x over 2, is I would always make that into a positive by moving it across to the other side. So instead on this one, if we went with the first step of adding x over 2 to both sides, we'd end up with 8 equals 3 plus x over 2, because you've added it to both sides, so it needs to go on the right hand side now. 8 equals 3 plus x over 2. Then minus 3 from both sides, so you get 5 equals x over 2. And then the final step would be to double it, because it's x divided by 2. You need to multiply by 2, you get 10 equals x. Or x equals 10. It's normally written with the algebraic letter on the left, but it does not matter which way round you write that. X equals 10 or 10 equals x means exactly the same thing there. Okay, so got a few more of these bar models. So again, I would like you to draw these two for me and then have a go at solving them, and once again put your answer back into the original one via substitution to see if you've got that right. When you've done those two, see if you can write down, like again our fact families, any other equations you may have seen from those first two. So if you pause the video now, copy those into your books and have a go with clear working at solving those for me, please. Okay, welcome back. So on the first one, we've got 2b plus 8 equals 12. So if we want to do minus the 8, we'd get 2b equals 4, divided by 2, b equals 2. Okay, you could have had 12 minus 2b equals 8 as an alternative equation, or 12 minus 8 equals 2b, okay, or perhaps something else there as well. For the next one, question 3, 4c plus 3 equals 15, so we had minus 3 from both sides. 4c equals 12. Then, because there's 4 lots of c, we only want one lot, we divide by 4, so 4c equals 12, divide that by 4, c equals 3. Okay, and for that one, you may have had an alternate equation of 15 minus 4c equals 3, or 15 minus 3 equals 4c. Okay, now for this one, this is what we've talked about a little bit, is how the same equation could be rewritten, or in fact an operation done to the whole equation that actually means it's exactly the same. So there are 6 equations there. And what I'm telling you as a fact is, all of them have the same solution. So first of all, I would like you to go through, solve those 6 to ensure they have all got the same solution, and what is that solution, and then have a think about why have they all got the same solution? What's happened to the equations that mean it's the same solution? Okay, so once again, I'll pause the video for you, give you plenty of time to do that. That may take about 5 or 6 minutes to solve those and to figure out exactly why they're all the same solution. And then by all means, at the bottom it says as well, write 3 more equations that give the same solution. So it's still the same answer for A. Okay, so working through those, we should ultimately get the answer of A equals minus 2. Checking on the first one, we've got minus 4 plus 5 is 1. Second one, minus 8 plus 10 is 2. We've got those correct for all of it. A is minus 2. Now, to see why they've got the same solution, so if you look at the first one, 2a plus 5 equals 1. If you compare that to the second one, 4a plus 10 equals 2, you have doubled every value in that equation. So 2a doubled is 4a, 5 doubled is 10, 1 doubled is 2. It's exactly the same. It's just been enlarged twice. It's been multiplied by 2. Then on the far right one, note how they've just swapped the left and the right hand side around. So rather than 4a plus 10 equal 2, they've said 2 equals 10 plus 4a. Okay. means exactly the same thing there. And writing 4a plus 10, or 10 plus 4a, means exactly the same thing, because if we can remember, addition is commutative. It doesn't matter in the order. If I said 4 plus 6, or I said 6 plus 4, that would get to the same value. Just remember though, it's only addition and multiplication that follow that rule. Division and subtraction will not follow that rule. Okay, then on the ones below, 2a minus 1 equals minus 5. What we have done there is done a little bit of a rearranging. Okay, so we've moved across. If we think of our bar model, okay, we've got it on the top is an A, and a 5, and that all totals as a bar underneath that would be exactly the same width equals 1. Okay, we've just rearranged that to say 2a minus 1 equals minus 5. Okay. We've swapped the 5 onto the other side of the equation by minusing 5 from that side, and then we've taken 1 from the other, so we've just swapped those two numbers around, making them negatives. That then would be exactly the same. Okay. The second one on that bottom row, the middle one, 10 equals 2 minus 4a, we can see is very, very similar to the top right of 2 equals 10 plus 4a. The only difference is there, where it had plus 4a with the 10. If we were to take that away and do that to both sides, as we will always do to balance an equation, if you take away 4a, you get 2 minus 4a, and then 4a minus 4a is 0, so that's just the 10 on that side. So it's just rearranging that top right one. And then the bottom right-hand side, minus 2a minus 5 equals minus 1, is a rearranging of the bottom left one. On that one, bottom left, we had a positive 2a minus 1. We've taken away 2a from both sides. Again, we say both sides because we balance. And you can see that's then minus 2a minus 5 equals minus 1. Okay, so obviously there's a lot of different answers as well for the 3 more equations with the same solution you may have gone for as well. Depending on how confident you're feeling, you may have made them even more difficult, but as long as you can check via substitution they work, you can give yourself some marks for those as well. Okay, next batch. So we've got 5x plus 3 equals 28, 5x plus 28 equals 3, and once again, I'd like you to have a go at these. Write down the question, and it's asking which are most suited to be represented with a bar model. So by all means, do a drawing of a bar model there, solve them, get your answers for x each time, and then think there's a couple of them that might be a little bit more tricky with the bar model, so is it perhaps not the best method to use for everything. Okay, so looking at some answers. On the first one, 5x plus 3 equals 28, we'd minus 3 from both sides, so 5x equals 25. Then divide by 5 and get x equals 5. Okay, on the second one, 5x plus 28 equals 3. We'd minus 28 from both sides, 5x equals minus 25. Divide by 5, x equals minus 5. On the bottom left, remember again that we want to get the x's on its own, so the first thing we would do is deal with the negative, the minus 3. So we'd add 3 to get rid of that, to balance it to both sides. So x divided by 5 equals 31. Then because it's x divided by 5, we need to multiply by 5 to both sides. So 31 times 5 is 155, so x equals 155. Okay, bottom right one, you have to be very, very careful with the symbols on what it is showing there exactly. This time it's x minus 3. All of that is divided by 5, and that's equal to 28. So in this case, because it's x minus 5, all divided by 5, we would deal with that division divided by 5 first. So first step would be to multiply both sides by 5. So x minus 3 equals 28 times 5, which is 140. And then we would add the 3 to both sides, so x equals 143. Double check it, 143 minus 3 is 140, then divide by 5. Okay, that gets you to 28. You would perhaps expect there to be brackets around the x minus 3, just to show even clearer via BIDMAS that you would do x minus 3 as your first bit when solving that before the division. Okay, once again, some two-step equations there with some bar models that have been drawn out for you. Okay, there are 2 pages of questions here. So first page, I'll take you through nice and quickly for these 4. So hopefully now, as we're getting a little bit more confident, this should take about 2 minutes. So if you pause that, I'll put up some answers, check those, and then there's quite a few more on the next slide. Okay, so looking through on these, 3a plus 10 equals 19. You would subtract the 10 from both sides first to balance. 3a equals 9. Then divide by 3, because we've got 3 lots of a, and you'll get a equals 3. Next one, 2b plus 8 equals 12. Minus the 8, 2b equals 4. Divide by 2, b equals 2. Third one, subtract 3, so you get 4c equals 12. Divide by 4, c equals 3. And then the last one, you would subtract 10, 3d equals 15. Divide by 3, d equals 5. Okay. As promised, on the next ones, we've got 4 more. Apologies, not quite sure why there's some white lines on there. Okay, but I'll just read those out just to make them clearer for you. So the first one is 4e plus 7 equals 27. The next one should say 3f plus 1 equals 10. Hopefully now we can actually interpret these ourselves from seeing the bar model. Okay, but that second one, number 6, is 3f plus 1 equals 10. So once again, pause it, and then we'll go through those 4 answers. Okay, so first one, we had minus 7 from both sides, so 4e equals 20. Divide by 4, e equals 5. Next one, 3f plus 1 equals 10. Minus 1 from both sides, 3f equals 9. Divide by 3, f equals 3. Next one, 2g plus 5 equals 10. Minus 5, 2g equals 5. Divide by 2, g equals 2.5, or you may have left it as a fraction. That's absolutely fine as well. Last one, 4h plus 4 equals 10, minus 4 from both sides, 4h equals 6, divide by 4, and h equals 1.5. Again, you may have left as a fraction there. Okay, we've got 10 more on here for you, so pause that video now, and you can draw, if you like, the bar models for those, but you do need to write out the question and show you're working with your arrows to make it clear what you're doing to one side, you're doing to the other to balance the equation still. Okay, answers are appearing now for this one. A equals 5, B equals 5. Sorry for the repetition there, there's quite a few of the same ones. And then we went a little bit different. Okay, so that last one it's 2 divided by 5. So 2 over 5, or if you left that as a decimal, 0.4. Okay. Okay, so if you just give yourself a score out of 10 for that as well. And this time, we are going to show the bar models with negatives. Okay, so it's a little bit trickier to show because previously we'd always done, say, 2x plus 10 equals a number. This time we're going to show it as 10 less than 2x. Okay, and this would perhaps be the best way to show that. If we were to minus 10 from there, and we've shaded that bit in that we need to take 10 away, we would know by now to balance this out and get rid of it, we would add 10 to both sides 2x equals 32, and then divide by 2, x equals 16. Okay, so just make sure you've got that shown in your books as well by pausing the video and just copying down that full example as it appears on the screen there for me, please. Okay, so here's a few more examples with the negative numbers. Okay, so if we have your work your way through those. Number 10, be very, very careful with again, because it's the one we touched on earlier, where you've got a negative algebraic letter. You've got minus 2j. So if we remember what we said we'd like to do to that, is first step is to make it positive by adding 2j in that case to both sides. So I'll go over that in a little more detail in a moment, but just remember that when you get to it and give that a go for me. So if you pause again, and then we'll go through some answers. Okay, welcome back then. So let's have a look at what we've got here. We should have 6, 9, 5, 7, 3, 6, 2.5, 3, and then again that last one I've written as a fraction, which is absolutely fine to do. You end up adding 15 to both sides, so 8i equals 22. You then need to divide by 8, so it's 22 over 8. Okay, or you could leave that as 2 and 6 over 8, which could be 2 3/4. But leaving it as 22 over 8 would be fine there, unless it specifically asks you to leave it as a mixed number. Okay, so as I say for number 10, the first step I'd like to see you do is to add 2j to both sides. That would then mean you've got 20 equals 10 plus 2j. Because remember, we're balancing, so we've added 2j to both sides. That then starts to look a little bit more familiar to things we've looked at already. So if you do then minus 10 from both sides, you get 10 equals 2j. Final step, divide by 2, 5 equals j. Or, as I say, we tend to, just in convention, write the letter first, so j equals 5, but it does mean exactly the same thing as 5 equals j. Okay, and the very last one there, unfortunately I've already filled in the answers for you, but if you just give that a go, and to see if you can follow that working through as well for me. Okay, please be aware as well that there are some worksheets in the folder for you to complete for the week. There's the standard ones that you'll have in your thick booklet that was given to you just before Easter. So if you work through the relevant one in there, and then the answer sheet will be provided. So if you then go through and mark your work, anything you've got wrong, correct in there. Any issues you have and you're unsure, if you send an email to your class teacher. And there's also a bonus worksheet in there, because I do like a code breaker, where you'll solve an equation and it will give you a corresponding letter. Then you can solve it to set up a particular phrase. That's just for those who'd like a little bit extra work on there and practice for this. It'll never do you any harm doing more than you need to. And then make sure as well the Hegarty videos will be told which numbers you need to look at. They'll be set on your Hegarty. That's what you need to complete by the end of the week and submit the quiz, where we'd like you to get, I believe, 80% or more. So make sure you do watch the videos again for extra help, and send that across to your class teacher, and they'll see that you've completed the relevant work there. Okay, so till next time, look after yourselves and keep safe out there, and keep up with the hard work then, guys. Thank you.